Hello, welcome to Astronautics for Exploit. This is Dr. Anyushola Ugundele. Optimism and challenges of spacecraft ground segment virtualization. Over the years, the space industry's shift from a government-centric model to a commercial-centric model driven by cost savings, technological innovation, and government policy changes has been helping humanity to accelerate spacecraft missions and catalyze the movement of spacecraft operations to the cloud through digital transformation strategies, such as virtualization of the ground segment. Government agencies are increasingly relying on commercial companies for launch services and satellites, while commercial entities are taking on more risk to develop new technologies for activities such as asteroid mining and satellite internet. This has resulted in a surge in private investment and new market opportunities. Presently, several organizations are virtualizing ground segments by converting analog radio frequency waveforms to digital radio frequency streams. Virtualizing the spacecraft ground segment involves decoupling software from specialized hardware and running it on commodity IT infrastructure, often in the cloud. This approach is driven by the rise of flexible software-defined satellites, low Earth orbit constellations, and the need for more agile, scalable, and cost-effective operations. The focus points are as follows: optimism of spacecraft ground segment virtualization and challenges of spacecraft ground segment virtualization. Optimism of spacecraft ground segment virtualization. Spacecraft ground segment virtualization involves converting traditional hardware-based infrastructure into software-based cloud-native systems. The fundamental shift enables ground station functions such as telemetry, tracking, and command to be managed through virtual servers, APIs, and automated software. Relationship between virtualization and physical system is shown in this picture. The optimism about spacecraft ground segment virtualization stems from virtualization's promise to reduce cost and increase agility in order to meet the demands of modern mega-constellations and dynamic missions. Transition presents significant challenges related to technical integration, security, and financial models. Copernicus ground segment is illustrated in this picture. Optimism of ground segment virtualization. Example factors are enhanced scalability and flexibility, cost reduction, innovation and interoperability, improved resilience and reliability. Illustration of the new age cloud technology is shown in this picture. Enhanced scalability and flexibility. Virtualization is essential for managing the sheer scale of LEO constellations, and this can involve thousands of satellites. The elastic nature of the cloud allows operators to rapidly scale their resources up or down in order to meet fluctuating demands. Accelerated deployment. Ability to deploy virtual servers with a few clicks reduces the manual effort and time required to set up services. Server virtualization in cloud computing is shown in this picture. Mission agility is another optimism of ground segment virtualization. Software-defined ground systems can be reconfigured dynamically in order to adapt to changing mission requirements, and this moves beyond the rigid custom-built systems of the past and allows for real-time adjustments and new business models. Firmware structure. Illustration of how virtualization works in cloud computing is shown in this picture. Cost reduction is another optimism. Virtualization shifts costs from capital expenditure for hardware to more flexible operational expenditure for software and cloud services. This eliminates expensive hardware refresh cycle. Increased efficiency. Automation of routine tasks allows human operators to focus on more complex critical decision making. Use cases of virtualization software is shown in this picture. Improved resilience and reliability is another optimism of ground segment virtualization. Digitizing RF signals allows data to be sent over networks to processing centers anywhere in the world, distributing operations and reducing reliance on fixed ground sites. This increases resilience against physical threats and environmental events. Automated failover. Virtualized ground segments can be designed with automated failover functions which quickly replace anomalies. Evolution of virtualization platform is shown in this picture. Leveraging 5G standards by adopting software-defined networking and leveraging terrestrial standards such as 5G, space industry can benefit from innovations developed for the mainstream telecommunications ecosystem. Enabling as a service model. Virtualization enables new business models such as ground software as a service, which provides operators with a flexible API-based solution. Different types of virtualization in cloud computing is shown in this picture. Challenges of spacecraft ground segment virtualization. The challenges are as follows. Technical and operational challenges. Decoupling hardware from software. For ground segments to be fully virtual, radio frequency signals must be digitized as close to the antenna as possible and transported over IP networks. This requires new standardized hardware and interfaces in order to replace legacy analog systems. Select ground segment for solidaries worldwide is shown in this picture. Interoperability and standardization. Satellite ground systems have historically been stovepiped with custom mission-specific hardware. A lack of universal standards makes it difficult to achieve true interoperability between different virtualized systems. Network topology of a satellite command and control system is shown in this picture. Spectrum management. The proliferation of satellites, especially LEO constellation, increases the risk of interference as multiple spacecraft compete for the same frequencies. Integrated ground system is shown in this picture. Hybrid system management. Many operators must manage a mix of legacy hardware and new virtualized systems during the transition. Integrating these different systems seamlessly adds complexity and cost. The control center at NASA's Jet Propulsion Lab is shown in this picture. Cybersecurity challenge. Increased attack surface. Moving to cloud-connected networks introduces many of the same cybersecurity risks found in traditional IT. This creates new vulnerabilities for adversaries to exploit through means of phishing, malware injection, and exploiting software weaknesses. Novel space ground segment is shown in this picture. Reliability of cloud infrastructure. While cloud providers offer robust security, operators become vulnerable to broader attacks, which target cloud infrastructure itself, including denial of service attacks. This could prevent critical commands from being sent to spacecraft. Satellite ground station is illustrated in this picture. Physical consequences is another cybersecurity challenge. A cyber attack on the virtualized ground system can have dangerous physical consequences, such as altering a satellite orbit or disabling its payload. A 2022 cyber attack on a commercial satellite network through a geopolitical conflict demonstrated the cascading effect of the vulnerability. Australia's fleet of Internet of Things ground station is shown in this picture. Financial and market challenges. For services that require continuous 24/7 operation, using the public cloud can be very expensive. The industry needs sustainable business models for cloud-based services in order to compete with on-premise solutions for high-demand applications. LEO satellite constellations Starlink, OneWeb, Comma, and Iridium, as shown, in this picture. Funding and talent expertise. As grant systems shift from hardware-centric to software-based, there is a corresponding shift in the required skill sets. A lack of experienced talent in network-centric and cloud technology poses a challenge for many legacy operators. Low Earth orbit constellation is shown in this picture. For more information, contact Astronautics for Exploit. You'll be watching and listening to Optimism and Challenges of Spacecraft Grant Segment Virtualization, presented by Dr. Anshola Ogundele, with the focus point Optimism of Spacecraft Grant Segment Virtualization and Challenges of Spacecraft Grant Segment Virtualization. Thank you.